Thank you to my co-presenters today, Brandon Romano from Clerk, Nathan Harvey from Google Cloud, and this is your host, Sahil from CodeRabbit. I'm also joined by my colleague, Kai Chow, who you might be able to see on the screen right now. And in this webinar, we wanted to cover what the DORA report, for those of you who might not be familiar with, the DevOps Research and Assessment Report. It's an annual report published by Google Cloud that covers the state of the software development industry. Nathan is one of the product managers and the DORA research lead at Google Cloud. He essentially runs the research survey behind it. And Nathan is going to walk us through this webinar where we will learn about the key findings from the latest DORA report. Brandon Romano is an architect who builds on scalable distributed systems at Clerk. Clerk is one of the CodeRabbit customers, and Brandon is going to talk us about how they have benefited from implementing AI code reviews. And those of you who might not be familiar with CodeRabbit, we are an AI code review company. We help to automate your code review process. So we'll bring the whole story together. And over the next 45 to 50 minutes or so, if you have any questions, please feel free to enter them in the Zoom chat. My colleagues will be monitoring the Zoom chat and they'll be happy to answer if you have any questions. So as I said, we'll cover the DORA survey. What do we see in terms of the impact of AI on coding more broadly? What are your colleagues, your industry peers reporting in the DORA survey as conducted by Nathan and the Google Cloud team? How has that led to an impact on the code review landscape specifically? What CodeRabbit is seeing from our vantage point as one of the pioneers in this code review space? And how should you think about the code review architecture? What is it that you as software engineers, as team leaders, should be thinking about when looking at your code review practices in your teams? And Brandon from Clerk will walk us through how they evaluated AI code reviews and the benefits that they saw. Time permitting, I'll do a demo at the end. All right. Now, Nathan, may I hand it over to you to introduce us to DORA and the findings from the latest DORA report?
Awesome. Thank you so much. And hello, everyone. My name is Nathan Harvey. I'm so excited to be here today. It's really a pleasure to get to join all of you and share with you some of the findings from DORA. And I'm really excited to see how Clerk has put some of these code review practices into place. And I definitely hope we have time for a demo because I love to watch CodeRabbit in action. So DORA, we publish a report every year. This year's report, well, the 2025 report, it's a brand new year here, but the 2025 report was called The State of AI-Assisted Software Development. You can download that report right by just click that QR code or follow the link there. We would love to give you time to download and read the report and then come back, but it's about 140 pages, so we're just going to push on through. We'll give you some of the highlights from the report today. But hope that you dig in a little bit later. So for those of you unfamiliar with DORA, I'll just kind of level set what DORA is. DORA is a research program. This research program has been running for over a decade now, and it really is research into the capabilities that enable technology-driven teams and organizations to thrive. Sahil mentioned our previous acronym, but we've de-acronymed DORA. So DORA doesn't stand for anything. But that sounds weird. So DORA stands for something. Of course, DORA stands for Get Better at Getting Better. We want to help you on this journey of continuous improvement and continuous delivery. So if I were to look back on 2025's research, what did we find? Well, first, a lot of our research comes from survey responses that we're able to get. So we go out into the world and we get as many survey responses as we can from organizations of every shape and size. While DORA does live within Google Cloud, this is not research on Google. It's not even about Google. The research is program and platform agnostic. In 2025, we were fortunate enough to hear from nearly 5,000 survey respondents from organizations, again, of every shape and size and in every industry. We augment those survey responses with qualitative data as well. So we have over 100 hours of qualitative data that we were looking at. And if I were to just summarize the report in three quick slides, here's what we found. AI's primary role in software development is that of an amplifier. And this is really, really important because, and you can go to the next slide there, Sahil, the greatest returns on AI investment come from a strategic focus on the underlying organizational system. You see, without this foundation, AI tends to create, you go to the next slide, AI tends to create localized pockets of productivity that are often lost to downstream chaos. Now, one of the ways that this really shows up is in the code review process. So we're going to spend a lot of time talking about that here on today's webinar. But I just want to share some other quick stats with you from our survey and from our findings from this year's report. So first and foremost, I know what a lot of you are thinking. It's a survey. Man, don't people lie on surveys? Well, this slide shows us that about 10% of people do lie. Oh, no, no, no. That's not what this slide shows. What this slide shows is the AI adoption. How many of our survey respondents are using AI at work? It was about 90%. So maybe just tongue in cheek, the 10% are lying. I bet they're using it at work. Or maybe 5% of those 10 or 50% of those 10% maybe are. But the point here is that AI adoption, using it professionally, is pretty much widespread. It's nearly universal. But with DORA, we want to understand more than just are you using it? We want to understand, are you relying on it? And in fact, we see that a large, significant portion of our survey respondents are relying on are relying on AI for work that they do every day. And in fact, they're using it a lot. On the next chart, we'll see the amount of time that people are spending using AI in a recent working day. And what I find really fascinating is that the median time spent directly interacting with AI during a recent workday was about 2 hours. Now, when you think about the role of a software engineer and look at some of the studies that are done about that profession, some of the studies that are done about that profession ask this question of about how much time does a software engineer spend actually writing code? And typically the ranges that are found in industry are between 10 and 30%. 2 hours in a day is about 30% of an 8-hour working day. So I think it's safe to say that if you're a software engineer and you're using AI, you're probably using AI for most of the code that you're writing every day or every week at work. Of course, there is a long tail here. There are a few folks that have 12 hours in a recent working day interacting with AI. I know it's fun, y'all, but please take a break. Think about your own mental health and well-being. All right, well, let's dig a little bit deeper here because we also want to understand how is it impacting productivity? And to be very clear, we ask people, how is AI impacting your productivity? So these are self-reported levels of productivity. Productivity is one of those things that can be very difficult to define. What do we mean when we say productivity? This is part of why we use just a self-reported factor or insight into productivity. What you can see here is that a large portion of our survey respondents, well, certainly well over 70%, are saying that it is increasing their productivity. With a very small proportion, that's what, 5% or so, saying it's slightly decreasing or even extremely decreasing productivity. But again, that's a very small numbers. Looking beyond individual productivity, we're software engineers. We work with code. How is interacting with and using AI in our life cycle actually impacting the quality of our underlying code base? And again, more than 50% are saying that the underlying code quality is actually improving. I think there's an interesting dichotomy here, though. We see that about 9% on the previous slide said that the impact on individual productivity was basically no impact. But the impact on code quality, no impact, was about 30% of folks, with about 10%, actually under 10%, saying it's decreasing the code quality. So again, this is interesting, and it gets back to these sort of fundamental questions. What does it mean to have a quality code base? What do we mean when we say productivity? Lots of things to consider there, and frankly, it's probably different for your team than it is from the team sitting next to you, never mind another organization. So as we go on into this, one of the things that we see is that my perception of productivity is improving, the code quality is improving, and yet we have maybe a challenge with trust. We asked, how much do you trust the quality of AI generated output? And you can see here that about 30% of people trust the quality a little or not at all. But you know what? I tend to be in camp somewhat here. I trust the quality of AI generated output somewhat. I want to review it, I want to understand it. And this is really any AI, whether that AI is code that I'm about to ship off to production. I definitely want to verify that that does what I expect it to do before I ship it. Or even, I don't know, an email that I'm about to send off to my senior director. I probably want to read that and not just have the AI send it off for me. So I think it's really healthy, this level of trust that we're seeing across the industry. Those people at the extreme ends, the I don't know, 11% of people that trust the output either a great deal or not at all. I'd like to sit down and have a coffee with you, and let's have a conversation about why that might be, and maybe some of the pitfalls or dangers that you might be walking into with that level of trust, that great deal or not at all. So let's look at how, we talked about people are relying on AI at work. Where are they relying on it? And interestingly here, and probably not surprising given sort of who our audience is, our target audience, and the topic that we're talking about here, the number one task is writing code. We're writing software, we're updating software, and so forth. That is really top of the pile here. But you have to go about halfway through before you actually find reviewing code. Let's see. Yeah, there it is. Code review. It's in fact it's lower than halfway or more than halfway down the stack rank here. This is really interesting because I see so many people using AI to write code, and a relatively small, but between writing code and reviewing code, a relatively small number reviewing code with AI. Frankly, if we go back to that trust paradox there, where you have like some level of trust, I think one of the best ways to build trust in anything is to use it more. So use begets trust. The more you use something, the more you trust it. And that's because you come to understand what to expect from it. And meeting expectations is a way to help build trust. So you use something more, you trust it more. You trust it more, you use it more. It's sort of this virtuous cycle that you get into. And so for those of you that are in the camp of like, I don't trust it at all, maybe it's better for you to start using AI in code reviews than it is to start using AI in writing code. Think about it. Reviewing code is something that often takes a long time, is kind of an arduous task, and it's safer than writing code. So maybe start building your experience with AI in a code review process. I think that that's a really healthy way to approach this if you're new. Now, there were a bunch of other things that we looked at across the report. One thing I really want to call out, though, is on the next slide, we looked at what are some of the capabilities that it's really important that we make true for AI. And one of the things that we find is that AI accessible internal data really has an impact on code quality and on the value that you get out of AI. In other words, for AI tools to really be useful, they need to be more than just generic assistants. They should become specialists, understanding the policies and the code and the ways of working within your organization. We see that when AI does have access to those internal data sources, individual effectiveness is increasing and code quality increases as well. Now, as we look back on the sort of the history of DORA, one of the things that's always been true with DORA is we have a center of gravity around software delivery performance. Software delivery performance is the mechanism or the measures that we use to understand how well can a team get change into the production environment. And we think about software delivery performance at two high-level characteristics or factors: throughput and stability. And so we want to understand and want to sort of measure and help teams improve the speed with which they can get changes into production and the stability of those changes. And you can see the 5 metrics that we use to measure those here. We look at lead time for changes. So how long does it take a change to get into the production environment from the developer's workstation? Deployment frequency, how frequently are you updating production? The failed deployment recovery time. We know that sometimes things break. So when when a deployment fails, how long does it take to get the system back to working? Your change fail rate, how frequently are those changes failing as you push them off to production? And then your deployment rework rate. How many of the deployments that you've done over the last period were not planned deployments, but were done in response to some sort of change failure or something like this? So, taken together, these metrics can really be used to measure the software delivery performance of any type of technology, any application that you're building, that you're deploying, that you're managing for users. And I said earlier that DORA has been around for over a decade. Well, we can go back to 2023. And this was the first time that we really looked into the sort of the code review process. And one of the things that we found there was that teams with faster code reviews have 50% higher software delivery performance. So they're improving both throughput and stability of their changes. There's some real powerful evidence there on why it makes sense to invest in your code review process. Okay, let's take a look at AI's impact across software delivery performance. This chart kind of shows you what happens as we look at our data if we increase the amount of AI adoption. So we essentially are running some simulations across our data and saying if we look at these teams and we keep everything the same except the level of AI adoption, what if we increase that? How does that impact the outcomes that we care about? Outcomes like individual effectiveness, software delivery, instability, and so forth, the things on the y axis or the vertical axis on the left hand side. And what we see is that as you increase the amount of AI you're using in your system, there are two big areas that I want to just point out here, and they're on the next slide here: software delivery instability and software delivery throughput. We'll start with throughput, which is the lower of the two sort of highlighted rows here. Software delivery throughput, we see increases. It increases because it's to the right-hand side of that dashed line that goes up the middle. So essentially what we're saying is if we keep everything equal, but increase the amount of AI adoption on a team, we expect software delivery throughput to increase. Now, the higher level highlighted row there that we see is software delivery instability. And so we also see that software delivery instability is increasing. Remember, the way that we measure stability is your change failure rate. So how many of the changes that you're pushing to production cause an O expletive moment. They cause you or your team to immediately respond to that production deployment, maybe rolling it back or pushing forward a hot fix. And then the other piece that goes into that stability measure is your deployment rework rate. How many of your deployments are unplanned? So what we're seeing today is as you increase AI adoption, your change failure rate goes up and the amount of unplanned or reworked deployments that you have to do goes up. That's not a good thing. We want to improve the stability of software delivery performance so that we can consistently and regularly deliver value to our customers. And we know that software delivery performance is really impacted by that code review process. So, Sahil, I'm going to hand things back to you because I know CodeRabbit is highly focused on this whole code review process.
Thank you so much, Nathan. That was a great deep dive into the DORA findings and definitely resonates with what we've been seeing here at CodeRabbit amongst our customers. But to introduce CodeRabbit to anybody on the webinar who may not have heard about us, we are an AI code review platform. We were launched in 2023. Our co-founders were engineering leaders in their own right when they were back in 2023. AI, ChatGPT had just come out, Copilot had just come out, and their engineers wanted to adopt Copilot. And what they noticed was their PRs had started, number of PRs had started to go up, but the feature release velocity hadn't really been going up. And so they noticed that there's going to be a downstream impact of using AI for this increased throughput that Nathan also noticed in the DORA report, but not really being able to ship out faster in production if you don't unblock the code review bottleneck. So that's why we built this startup back in 2023, coming up to 3 years now, which almost feels like a decade in the AI startup ecosystem. But we've grown pretty rapidly. We're doing double-digit percentage growth month over month. I live here in San Francisco, and I sometimes joke with my friends here in SF that we measure our time in SF in terms of our boom and bust cycles. So I've lived through the Uber for X era, and I've lived through the crypto or Web3 for X era, and now it seems like the AI agents for X era, where everything's just everyone's just looking to figure out how to use AI to make their work better. And we found some great market validation. So just names of some customers who use us. And to again, just to reiterate the point I was making, why did we look at the code review space specifically? Because with the adoption of AI coding, as we noticed in the DORA report, there is now a huge acceleration in the code generation velocity, the code throughput. But hopefully, you're not putting that code into production without doing an independent review. Hopefully, we're not just saying, okay, great, the code is ready. My coding agent, whatever coding agent that you use, has written the code, and of course, it's going to be perfect. There's not going to be any downtime. There's not going to be any failures. There's not going to be any memory leaks. No, we know that doesn't work. In fact, that does show up with that increased software instability with the adoption of AI, having to roll back all those changes that your coding agents push out. But clearly, review is a process that's really tedious if you do it manually. And not just the amount of code that is being generated, it just means that we cannot keep doing code reviews unless all we want to do is like 4 hours or 5 hours of code reviews every day, which I don't know about you, but definitely doesn't sound exciting to me. We also did an analysis here at CodeRabbit. This is a report. We will send out this webinar recording with all the relevant links to the DORA report and the slides and everything else, where we looked at the some of the PRs that we could identify as either co-authored between a coding agent and a human, or purely coding agent authored PRs, versus others where we did not see any signs of the PRs having significant coding agent involvement. So we sort of did this as an open source PR analysis between human written code versus human plus AI co-authored code. And we noticed that there was a 40% increase in the critical bugs in the PRs that were co-authored between humans and AI coding agents. So that also sort of generally aligns with the DORA findings, where we notice that we're shipping out a lot more throughput, but there's a lot more of the bugs that are shipping out, and that leads to more software instability. And as I said, one way would be if I just go and I try and read every single line of code written by Cursor or Claude Code or Copilot or Codex or whatever your coding agent of choice is. But then all that I'll be doing is probably drinking a lot of Celsius and doing a lot of code reviews. And that's clearly not a recipe to increase your actual feature release velocity. And at the end of the day, really what matters is how fast do you get your features shipped out, how quickly do you burn down your backlog, how quickly do you address bugs, and not just how quickly you write your code. Clearly, writing faster code is going to help us get to faster features being shipped out, but not if we leave the code reviews to be a manual process, or worse, have no code reviews at all. So this is where CodeRabbit comes in. We sit parallel to your coding agents, right? We're completely agnostic to the rest of your tech stack. Doesn't matter what ID you use. Today we support VS Code. We also have JetBrains on our roadmap. Uh, we work with practically every coding agent. Or for the 5% of you that still write code manually, yeah, we'll still review your code manually. It doesn't have to be written by an AI agent. But as Nathan said, I think there's probably just a handful of people left who might still be doing hand coding. So we sit primarily in your CI/CD pipeline when you open a pull request or a merge request. If you're using GitHub, GitLab, we also support Azure DevOps and Bitbucket. So it's really a team product, right? Your pull requests are where your entire team's code comes together. You can have a bunch of different reviews in your IDE, but that's you, the independent developer. We also have a CLI agent and we have an IDE extension that works in VS Code and all VS Code derivatives. But those would be an individual users, just my code that I'll be reviewing with CodeRabbit or with any other code reviewer. The pull request is where all of your commits are coming together. So that's where we've always done the team-wide reviews, right? And that's where the true benefit of having a collaborative approach to code reviews and leveraging the power of AI and leveraging the power of uh, intelligent context building. That's really where you can speed up your code reviews and catch more bugs. The local reviews are great to do a first pass of your own code before you send it to a pull request, but you're still going to be opening a pull request where the whole feature with commits from different people come together, and you're still going to be doing a review in your PRs, and that's really where most of the value of CodeRabbit comes in. This is my favorite slide. I love going into our product architecture. So I'll try and explain this in a reasonable amount of detail. Please keep your questions coming. My colleagues are monitoring the webinar chat, so they'll be happy to answer any questions that you have. So essentially, we have a couple of different ways of deploying. Most of our customers use our SaaS platform, but we do have a self-hosted container image for our security and compliance conscious customers. But in either architecture, we start by cloning your repository, and that cloned repository lives in an isolated sandbox. That sandbox is only used to run real-time reviews, and after the reviews are done, the sandbox is destroyed, the clone of your repository is destroyed, unless you choose to enable caching. In that sandbox, we start by first of all doing some basic linter and security scanner checks. We have built-in config files for the various open source linters. You can provide your own config files, and then we'll use the rules from your config files. Otherwise, we bring our own opinionated config files with some extremely basic scanners. And this triggers in our pull request whenever you open a pull request. So it's automatically triggered event based, or you can use our CLI agent to trigger it on demand, or use our VS Code extension to trigger it on demand. In each case, we will do also a real-time code graph analysis. So this is essentially looking at function call dependencies across my different files, across my different directories. Today we do that within a single repository, but we are working on multi-repository code graph analysis. It's on our near-term roadmap. What this helps in doing is, if I made changes to a certain variable in a certain file, what are its downstream API calls and what are its downstream dependencies? Maybe those are outside my PR diff. Maybe the downstream dependencies wouldn't even be top of mind if all I was doing was looking at my PR diff. And that's really where we start to expand our field of view beyond just the code in your PR. We really understand all of those dependencies and point those out. Hey, you made a certain change in a PR, it's going to cause breakage downstream in other code in other files. We bring in a lot of other additional context. As I'm sure everyone on this webinar is familiar, LLMs are great, but they are a great brain. The brain is only as good as the information that you feed it. An example I often like to use is, if I go to my car mechanic and I tell them, hey, can you fix my car? The mechanic is going to counter question me and is going to ask me, what's happening? Are your brakes okay? Is your engine check light on? Do your tires look like they need replacing? What do you want me to fix? What do you want me to take a look at? That's context, right? And so that's the context that the LLMs need in order to do a thorough, deep review that really helps you find more hidden bugs and more difficult to find bugs than simple bug scans. And we get that context in a whole bunch of different ways. Um, we have an MCP client, so you can bring in any kind of public MCP server. Doesn't matter if that's a Jira, Notion, Sentry, anything that has a public MCP server. Our review agent will intelligently figure out there is certain code I should look at. Do I have access to requirements? Do I have access to logs? Do I have access to other data that could potentially help me understand the code better? You can provide your Jira tickets, linear issues, You can add those to your PRs, and we will treat those as requirements to validate the code against. If you already have your cursor rules file or GitHub instructions file and so on, we will look at those. What are the kind of coding standards that you wanted your coding agent to implement? And basically do a second pass and make sure, oh, did the coding agent actually follow the rules that you asked for? We build an index of your PR and index of your code to really understand how does different parts of your code work, and that's building a mental model, so to speak, of your code base. And there is a chat interface where you can interact with CodeRabbit, and I'll show you in the demo, and we'll create new learnings based on your chat, based on your feedback. You can also provide custom rules just in natural language instructions. Those rules are review specific. Things like make sure you validate against the latest JavaScript style guide or whatever kind of reviews that you rules that you want to add. Another key thing that we do is we don't simply rely on the LLM output and treat that as gospel. Hopefully, we have enough experience by this time to know to get a good sense of when the LLM might hallucinate. And so we have a different verification agent that, for example, takes LLM's feedback and validates that against your code. If the LLM is saying, hey, this API call needs to be updated, well, does that API call actually exist? Or did the LLM just make up an API key or a function variable completely? It happens far more than you would think. So we completely independent of the reviews done by the LLMs, we have a completely different verification agent that verifies, is this review actually going to make sense if I apply that to your code base? And we do that all in that same sandbox. And we grade those reviews, and then we filter out the low quality reviews. Ultimately, everything gets sent back to your pull request or your merge request as your review comments. So again, just to bring the whole story together, right? So just throwing your PR diff at the LLM is not a code review. We can't just give the PR link to the same coding agent and ask it to review its own work, right? Self reviews are not a thing. There is a reason why the reviews were always done by your senior colleague when we were doing reviews manually, and that's why the reviews still need to continue to be independent of the coding agent. We believe, and we've seen this, from the other customers, that having an architecturally independent entity evaluate the coding agent's work helps to catch more bugs. And the better context that you build for the LLMs, the better job the LLMs will do. And that context comes from things like the outputs of your linter checks, your custom rules, knowledge of your code base. How is your code base actually functioning? What were you trying to do? Running a real-time web search. Sometimes the LLM is not going to be fully up to date. Maybe there's a new security patch that came out. Maybe there's a new vulnerability that was publicly announced, and the LLM might not have been fully up to date with it. So we run a web search tool under the hood to make sure we also include that in the reviews, and identifying your dependency map. All of this happens mostly without any input from the user. What we do advise the users is to do things like provide us your linter config files if you would like, provide your issue tickets in your review process, the issue tickets that have sort of like requirements, or even a PRD if you're building a big feature and there's a PRD with it, or if there is some internal documentation, maybe Confluent documentation or Notion or Google Docs or anything. Provide those in the review process, and that helps to build a better context around the reviews and give feedback to the review agent from the chat interface. And what does it actually boil down to? We have had the biggest value is in companies that were still doing manual code reviews. They can now just completely get reviews start immediately. You don't have to rely on your colleague that's sitting in a different time zone to be available. So there's a huge drop in the initial time to review. But also, some of our customers report that before, when they were doing manual code reviews, they would have two senior developers look at the PR, right, just to have another layer of redundancy. And now with CodeRabbit implemented, they can just rely on one human reviewer plus CodeRabbit acting as the other alternative to the human reviewer. So that frees up the time of one developer from the entire review cycle. And I'll, at the end of the day, all we want to see is, are we shipping out more code? So these are real metrics reported by Groupon. I don't have their name over here, but these are public metrics. We have them on our case study website. That Groupon was able to ship 36% more PRs after implementing AI code reviews. And who better to talk about what this actually means for them in real life than somebody who works with AI coding agents and AI code reviews on a day-to-day basis. Brandon, I would love to hand it over to you to introduce what Clerk does and what has your experience been like.
Absolutely. Thanks for inviting me here today. I'm really excited to be included on this. Specifically, I'm super excited to see all the results of the DORA report. So Nathan, your talk was really exciting. I can confirm that I'm also in the somewhat camp for trusting AI output. Although I'm also in the somewhat camp for trusting human code output. So I think that AI has reached parity here. And Sahil, I also too can confirm you made a joke about Celsius. I can confirm that my human-powered code reviews also run on Celsius. But my AI code reviews run on CodeRabbit, which is why I'm here today. I'm a senior staff software engineer at Clerk. For those of you who are unfamiliar, Clerk is a comprehensive authentication and user management platform. Basically, we focus on developer experience. So we provide front-end SDKs so you can add authentication to your application without worrying all of the complexities of authentication, of which there are many, trust me. We're also pretty happy CodeRabbit customers, which is why I'm here today. So specifically for at Clerk, our AI adoption is really broad. We very much encourage experimentation by the developers on our teams to try new tools. I think that the AI landscape, kind of as the DORA report kind of shows, is kind of ever evolving, and just a few years ago we weren't using AI. There's so many different things that I think are coming out today, and we're still figuring everything out. So we very much encourage everybody to try the new tools. We do have some standards and some daily drivers. So a lot of our developers are on Cursor. We use Claude. We use Codex. We use a bunch of agents. We can kick them off in both Linear and Slack. And obviously, we use CodeRabbit for our code review. So specifically at Clerk, because the kind of the space that we are in, we have a few core considerations for our entire software development lifecycle, but also too in our code review process. Specifically, our tolerance for any downtime is basically zero. So we very much make sure that we're not doing anything that's going to introduce any instability into our systems. So we're pretty specific in our code review process about this. And then additionally as well, security is critical. We are an authentication provider, so customers are trusting us with their security. So we very much have a security first culture. And specifically, kind of how this pertains to CodeRabbit, a small anecdote that I have to share is that kind of as these AI software tools, you could spin up an agent, kind of has come to the scene. It kind of expands the surface area of people within our company that actually can provide some meaningful contributions to the code base, including non-developers. So one thing that we were nervous about with kind of allowing our non-developers, our non-backend developers working on the backend, et cetera, we were worried about any security issues that might come up that are hard to catch in a review. By a human that doesn't have the context. So we specifically have tuned our CodeRabbit configuration to be really, really sensitive to these specific things. And it really allowed us and kind of enabled us to go and say, okay, there can be other people outside of the core developers who can actually contribute code to our code base, because we kind of have that backstop of CodeRabbit on the other side, which is really exciting and really empowering. So I want to run through a few examples, all of which are PRs that I have submitted. I'm not going to subject you. I'll only subject you to my bad code and not to any other bad code that we've seen. So let's jump through these things. So one such thing that CodeRabbit helps us with, which is kind of the obvious about CodeRabbit, is it helps us from shipping bugs to production. So here's a example of a some code that I pushed, where basically there's possible that there was going to be a nil pointer dereference in the code right underneath of this. This is a really hard thing for a human to catch because it requires pretty deep understanding of the APIs that you have built inside of your system. So there is kind of this level of when a human is reviewing your code, they're really great at providing this high level architectural design feedback of, okay, I think you've handled this the right way. But it's really hard to catch those, like, I need to know the exact nuances of the APIs. So this was an example of a bug that would probably have hit production. Maybe one of the human reviewers on my team, which we still do include a human review process on every single PR, but this would have probably been hard to catch. So CodeRabbit caught it. It prevented an issue from making its way. I was able to fix it immediately, and there was no issue. So it saves us from shipping bugs to production. Another thing that CodeRabbit is really great at is understanding intent. As Sahil kind of mentioned with the architecture of CodeRabbit, it kind of marries all of this context into a single place for the CodeRabbit agents to be able to kind of provide you really, really helpful feedback. Here's one such example where there was a difference between the comment, which was my actual intent, and the actual implementation of a regular expression, which are notoriously, famously hard to write, hard to read, hard to review. CodeRabbit was able to say, hey, you said in your comment that this was this followed by at least 31 characters, but your regular expression actually requires exactly 31 characters. So it's really quick to flag discrepancies. It pulls this context from your tests, from the APIs that you're pulling in from a bunch of different places. It's really, really helpful to flag these discrepancies that would eventually come up as bugs later on in once you ship it to production. For the next one, yeah, so again, just like saving time by bringing issues forward. So here's an issue that I brought up where here was a Docker file that I was building. We build this in our CI/CD pipeline when we are kind of deploying. Inside of my Docker file, I've referenced a file that did not exist. Because I'm a lazy developer, I did not test this locally. I just wrote the code and I just submitted a PR. CodeRabbit was quick to say, hey, this file doesn't exist. This will cause a build failure. This would have taken, so okay, I pushed up the PR. I had to wait for, our CI tests to run, so 10 minutes. And then I release this, and then it goes and deploys, and then it goes and fails. That would have been another 10 minutes. I would have had to submit another PR. Long story short, it would have been like 40 minutes end to end if either a human or CodeRabbit hadn't caught this bug. It just saves me some cycles. I didn't have to go and actually release it to discover there was actually a bug here. Saves me some time. A quick, comment that pops up within a few minutes within CodeRabbit. I plug in the fix. We're happy. It deployed and it worked. I can also confirm that this built correctly after I deployed it. And then so one thing about CodeRabbit that I actually really like is sometimes we actually disagree. So here's an example, which I have completely blurred out, but I've basically explained that, like, actually this is it's asking, hey, updated out is never auto updated. I'm like, oh, under the hood, this column gets managed by an ORM library, so we don't need to actually update it. So CodeRabbit then goes and takes this as a learning, which is a kind of a feature of CodeRabbit, which I really, really like, because once I provide this context, CodeRabbit then goes and takes this context in future PRs, and it knows, oh, okay, I don't need to provide this feedback, this category feedback again, because now I understand a little bit more about my code. So this happens often. The interface for providing feedback is really natural. Like, you don't have to train a team member to say how to interface with CodeRabbit. It's how you interface with a human PR code review. And then the last thing that I'll have to say about this is I particularly often appreciate comments from CodeRabbit that are not inherently actionable or not inherently a bug, because it leads me to reflect further on my code. And this can, I think that generally that's never a bad thing, but it often leads me to ask, why was it confused about this particular thing? Is there something that needs to be documented more in our code? Is there something specifically that I'm doing that's not super clear? So often CodeRabbit's comments that are not necessarily actionable are often pretty good proxies that maybe something is not as clear as it ought to be. So I pretty much appreciate those comments as well.
Perfect. Thank you so much, Brandon, for walking us through. Those were great examples. I'm not sure if I can actually show too many other examples that are better than those. So instead, what I'm going to do is walk you through how you can actually get started with using CodeRabbit. If anybody on this webinar wants to later today, go ahead and give it a try. It's a very quick and simple product to install and use. It's almost completely self-serve. So you go to our website and you will see the start a free trial link over here. The first time you go over there, it's going to ask you to log in with your preferred platform. So let's say if you're using GitHub or something, just use your GitHub credentials. Make sure you are logged into GitHub with the same org that you where you want to use CodeRabbit. Sometimes I do see people a lot have access to multiple orgs and they're in a different org, and then CodeRabbit will only be able to see the org where you're logged into GitHub at that time. So I will log in into one of my demo environments. There's multiple repositories. The first time you come in, it will prompt you, hey, do you want to pick and choose which repositories you want to give access to? It will take you to the GitHub apps workflow where you give us access to your GitHub repos and you can pick and choose which repos you want to give us access to. There's a bunch of config settings. They are set for most people, but as I said before, the value of the reviews really shines if you give us access to your ticketing system, whether that's Jira, Linear, if you bring in any additional MCP server that might have critical information that should be included in reviews. For example, a lot of people give us access to Context 7 for documentation or Notion if they're using it. Some people won't like to add custom review instructions. So you can go ahead and add those, uh, provide the file path where your coding guidelines files might be, or you can provide your path-based instructions. For example, for files in a certain directory, do XYZ. So there's a lot of settings over here. I tend to usually leave these on default. And let's say I am in my GitHub repo. So there is some code that I was building over here to train the SDRs in our team. And I will open a new PR. The reviews do take 5 to 7 minutes. So I'm just triggering the review. I put this over here to allow CodeRabbit to just auto-generate the PR title and the description as it goes through the review process. It will take, as I said, 5 to 7 minutes. So I'm going to jump through and actually show you in the same PR. So this is the literally the same repo and the same commits in the PR. I've run those before. So you can see over here the summary is created by CodeRabbit. There's a detailed file by file walkthrough telling me what are the actual files that are included in these commits and what has changed in those. And I really like these sequence diagrams. They help me get a visual understanding of the overall architecture at a system level, right? So for example, in this case, the API server is making calls to database and calling some pusher service. And then we start to get into the more nitty and gritty of it. So these are the review comments. And this is what Brandon was showing you from his PRs. And you can go through these. The next time you open a PR, CodeRabbit might find some really useful bugs. I'll show you a few examples of some other bugs that we found in other open source repos. So this is another open source repo where, for example, there was missing error handling. This is something we quite often see in AI generated code, where the coding agents may not have thought about all of the edge case scenarios. And we have deliberately trained our review agent to think about all of these kinds of edge cases and how are things going to behave at scale. This is one of those cases where there is something that would have broken outside the PR diff, right? So this is coming from our code graph analysis, where we understand the dependencies of all the functions and the API calls. So this is telling me that the code that is changing in this PR can potentially create a race condition with certain other function calls that are outside the PR diff. So it even catches code that can potentially be needs to be changed outside the PR diff. Memory leaks, I see these come up quite often. Memory leaks, SQL injection, They're very easy to slip through. And let's say when you're ready to, you agree with the feedback and you want to actually incorporate it, you can either just copy this prompt, which is basically the same thing over here, just convert it into a prompt for your coding agent. Or if this was something that can be committed directly in this PR, then you can just there is a one click to commit in the GitHub PRs. This is not my PR, so I cannot commit it, but there would typically be a a committable suggestion button over here. So you can add this as a new commit in the same PR, or you can take it to your coding agent and have your coding agent incorporated. This is a really nice example that I like. In this case, there wasn't actually anything wrong with the code per se. It's just that the developer was calling certain EC2 instances, in this case, T3 family EC2 instances, whereas their requirements, as we found from um, their linear integration, the requirements were actually for a different instance family. Turns out, yeah. So this is saying this is going to cause instance type deployment failure because the requirements that the agent found were to use T4 family. So we were given access to linear. We went in and found the linear ticket, and the linear ticket said, no, 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 you should be using T4. The developer just left this as T3. So this is a sort of a mismatch with the requirements. This is why it is really critical to have all of those requirements given access to during code review process. All right. We're nearly at the top of the hour, so just bringing everything back together. Very quick and easy for you to get started, right? We noticed from the DevOps, the DORA report, that by adopting the AI coding agents, we are shipping a lot more code, but it's potentially leading to increase in code instability. And a lot of that can be reduced by having a different architecture, a different mindset during the code review process. Typically, our customers see that they increase their PR merge time. They free up a lot of their developer time. If they were using two human developers before, CodeRabbit tends to come down to one human developer plus the AI code reviews. And you will typically be able to, the AI code reviews will typically be able to find more bugs that the humans can often miss. Things like memory leaks and race conditions are really hard to catch if you are doing manual code reviews. And we're happy to work with you to figure this out. Happy to get you started and evaluate what your ROI might be after you've implemented code reviews. And the ROI basically comes from the value of the developer time being saved, right? As Brandon was saying, if the humans had to catch those, they might have taken 40 minutes, 50 minutes, whereas the AI catches it far more quickly, and you can make those changes a lot more quickly. So there's the developer time saved, and then the value of the bugs being caught before they get into production, the value of the not having production downtimes. That's how we think about the ROI of implementing AI code reviews. Well, that's it. Thank you to everyone for sticking around. So your next action items, go to the DORA website. That's dora.dev. Download the DORA report. Think through what your own organization has implemented in terms of AI practices and what the DORA report is finding in its survey results, and how do your practices match up against the best practices as we see in the DORA report. If you're ready to get started with AI code reviews, we'd be happy to reach out to you, or you can just go to our website, start a free trial, hook it up to your repo. The next time you open a pull request, you will see the AI code reviews, and hopefully they will catch more bugs than you would have otherwise. If you have any questions, please feel free to get back to us, hello@coderabbit.ai, and we will stick around for a couple of more minutes to answer any questions in the chat. And please join me in thanking our panelists, Brandon Romano and Nathan Harvey from Clerk and Google Cloud, respectively, as well as my colleagues Kai and John, who are monitoring the Zoom chat to help you with your questions. Thank you for your time today. Have a great day. Have a great weekend, and look forward to connecting with you later down the line. Thank you, everyone.
And so we have a good question in the chat that I
Yeah.
wanted to ask to you live. So the question was, how does CodeRabbit think AI-assisted development code review is gonna evolve in the next 1 to 2 years?
Yeah, 1 to 2 years is an insane amount of time. Let's think about the next 3 to 6 months. One of the things that important things that we are noticing in the industry is the importance of having a thorough plan before you begin to even do any coding, right? It's almost like we are seeing that the more time you spend in planning your project, your feature, your task, the better your end results are. So there is a mindset education and sort of a need to tie this, spend more time in thinking and planning out before you start doing the coding, but then have that plan in your mind when you start the review process. Don't review in isolation, review with your plan in mind. That's something that we are starting to see pick up a lot. And that's something that I expect, in 3 months, in 6 months, potentially in the next DORA report, we might see a lot more of the developers talking about. The more time I spend planning before I send my plan to the coding agent, the better my output is. And the more I include that plan in my reviews, the fewer bugs I ship.
I'd love to weigh in there as well, if you don't mind. I
Please,
think
please.
that I think when it comes to code review, like there's always been this ideal state for code review in my mind. The ideal state of code review is pair programming. In other words, eliminate the need for code review. We're live reviewing the code with two humans all at once. Now, many organizations are fearful of this, and maybe even some of your compliance policies don't allow for that. So then I think the next question is, as you're laying in AI assistance on the code review process, we can get back to a deeper organizational question of why do we do code review? Because code review, yes, of course, one of the reasons we do it is to catch bugs. Let's be honest, we're pretty bad at catching bugs. Even with the code review process, bugs still tend to get through. So maybe the AI can help us there. But another really important piece of our code review process is for knowledge sharing and building up or eliminating single points of failure when it comes to understanding this portion of the code. And then if we prioritize code review as a knowledge sharing activity for humans, you also might start asking crazy questions like, does a code review have to block a production deploy? Does it have to get in the way of that? I would argue that today it is good to have your code reviews before you do a deploy, because if you say it's a non-blocking code review, you might never do your code reviews. But if you can prioritize the knowledge sharing because you have the trust in your AI coding assistant and the AI code review assistant that it's going to catch the most critical bugs and do at least as good a job as the humans, I think it really starts to change how we think about the necessity of and the goals of code review. To me, that's super exciting.
Thank you. Thank you, Nathan. Yes, no, absolutely. Any other questions, John or Kai, that you want to highlight from the chat?
No, I think we had a really good panel today, and all the information that was requested, such as a recording of this webinar, the slide decks that Nathan had presented, we'll be happy to include those in a follow-up once we conclude. And if there's anything else that's of interest, please feel free to reach out to us, especially on LinkedIn as well. Always happy to interact and answer any questions from there too.
Thanks, Guy. And just addressing the point about the Claude plugin, and yes, that's correct. We do now have a plugin that you can use to review your code right within your Claude interface. But again, that is still going to be at an individual developer level. That doesn't negate the need for doing the team-wide reviews at the pull request. So we still see that plugin as an addendum, as an add-on to your PR reviews and not as a replacement of it. The more you do your reviews locally, the less noisy your PR will be in terms of comments, but it's not going to replace doing the reviews in the PRs.
I think it looks like we had one more question in the Q&A. John, would you be able to help add some more color to this, please?
Yeah, it looks like the question was around the difference between CodeRabbit and Copilot. And I know we have some documentation around that, and we're definitely happy to follow up and share some of that after the call.
Yeah, and the high level thing that I would say is Copilot is a great coding assistant, but There's a reason why we never did self-reviews in the pre-AI era, right? You shouldn't be relying on Copilot to review its own code. Copilot should be writing the code, and our customers use CodeRabbit to review Copilot's code. And the reason for that is because code review is a completely different architecture. You need to provide a lot of the context and a different way of providing the context. And you need to be architecturally independent of the coding agent to truly evaluate its code in an unbiased way. So what we see is people use Cursor, Copilot, everything else for code generation, and then bring in an independent layer, code review layer.
And just from personal experience as well, CodeRabbit is better at the code review part than Copilot, and also to Cursor. I've used them both. CodeRabbit has more accurate hits and less misses. So
Thank you, Brandon. And part of the reason for that is because we are a hyper-focused code review company. We spend 99% of our time thinking about code reviews, whereas Copilot and Cursor, they're first and foremost a code generation company. So they'll naturally spend less time on code reviews.